Okay, this problem we are trying to find an expression for the stopping distance d in terms of the initial speed vi, the response time tr of the driver to the visual signal, and the magnitude of a prime of the car's deceleration. And then using a square fit data to find a prime and tr. So how I approach this problem is that first I set up a graph, velocity versus time, and as you can see, the initial velocity is constant throughout this whole distance until it hits tr, which is the reaction time. This is when the person applies the brakes, and then from there the car is decelerating at an acceleration of a negative acceleration all the way to 0, where the car stops. So the equation is split into two different distance. The first one is the initial velocity times the initial velocity and the reaction time. And in order to find that distance, I just find the area under the curve, which is basically just the vi times tr, as you can see right here. Distance 1 is vi times tr. And for distance 2, which is from tr to where it stops, I use the third equation in the kinematics equation, v squared times v naught squared plus 2 times the acceleration times the displacement, which is d2. Well, setting that this point is 0 to this point, which is d2, the displacement. Okay, so I just plug in what I know, which is add velocity at the end velocity, it equals 0 because that's when the car stops. And then v initial squared right there is v naught plus 2 times a times the displacement d2. And then I rearranged it, so I got d2 equals to negative vi squared divided by 2a. And I know that distance is d1 plus d2, because the total distance just equals to this times this one plus this one. So I got vi times tr, which is d1, plus d2, which is negative vi squared divided by 2a, which is this. So now I determined that this is a quadratic equation. So when I went to go plot my my velocity over the distance covered, I use, when I plot it, in order to find the coefficients in front of these, which is the tr, and in front of this one, I used a quadratic autofit line, and I got the numbers for a 0.05529, and for a coefficient of b I got 0.6599. And the next question is to find a prime and the reaction time. So I just set the 0.05529, which is the coefficient over here, to equal to the negative of 1 over 2a, and I solved for that, and I got the acceleration is at a negative 9.043 meters per per second. And TR is just the coefficient of the VI, which is 0.6599 seconds. So that's his reaction time, 0.6599 seconds. Yeah, I think that's it.